Hi everyone, let's take a look at how to draw the graph of the equation of a straight line by using the most introductory method, using a table of values. Let's try a question. Let's graph the straight line of 2x plus y equals -3. But how do we know it's the equation of a straight line? Simple. It has an x in it and a y in it. The x and the y are not multiplied together. They are not divided. There are no square roots to the x or y, and there are no exponents or indices to the x or the y. To be slightly more exact, this form here is something x plus something y equals something. That form is actually called standard form. But we're going to talk more about that another time. Back to graphing the straight line. This is really easy. All I need is only 2 points to graph a straight line, right? Right. Okay, I know how to find one real easy. I can just pick any value of x. Let's choose x equals 1. Here we go. All I have to do is put x equals 1 into the equation and I get a y value. That gives me 1 point. X equals 1 instead of writing x. And here we go. 2 times 1. 2 plus y equals -3. To solve for y, we want to get y alone on the left-hand side. Subtract 2 from both sides. The 2 and the -2 then cancel out. And then we are left with y equals -3 minus 2, which is -5. Well, that gives me my first point. How easy is this? We used x equals 1, so that is my x-coordinate. And then we got y equals -5. That is my y-coordinate. There's our first point. Let's put our first point on the coordinate plane. There's our first point, all done. But we still need one more point. Let's find another one. This time I might put in a random value of y. Let's try y equals -2. Into the equation, instead of y, let's put -2. Removing the brackets, this gives us 2x minus 2 equals -3. We want to get x alone on the left-hand side. So let's undo the -2 by adding 2 to both sides this time. The -2 and the +2 now cancel out. This leaves us with 2x equals -3 plus 2 is -1. To isolate x, we now need to undo 2 times x. How do we undo a 2 times? We divide by 2 on both sides. 2 divided by 2 cancel out and just become 1. This gives us a final x value of x equals -1/2. So we now have coordinates for our second point. The x-coordinate is x is -1/2. And our y-coordinate is, back up here, we chose y equals -2. We now have 2 points. Let's plot our second point. -1/2 minus 2. Now we have our 2 points. We can now graph our straight line. Hold on a minute. Are you seriously telling me this is supposed to be your lesson? Why, what's wrong? Well, yes, everything you've done so far is correct, and the 2 points and your line are correct. And yes, you are right about only needing 2 points, but what if you made a mistake with one of them? You wouldn't know, would you? And you said the lesson is about graphing a straight line using a table. Where's the table? And you're actually going to need at least 3 points. The first 2 to draw the line, and a third just to make sure everything lines up and there are no errors. And also, using a table is good because it makes everything look more organized, and you'll be able to see that the numbers will make a pattern. You won't be able to see any pattern with the way you're doing it, and don't forget to make them find the function form of the equation first. Rewrite the equation and do your job properly. Okay, settle down. You don't have to get so mad. I guess we gotta change the question to keep him happy. I beg your pardon, what did you say? Nothing. I didn't say anything. Here we go. The question has been rephrased. We are now going to first write the equation in something called function form. Function form means we write it as y on the left equals some other stuff on the right. When we write it in function form, it makes it very easy to use a table. To get y by itself on the left, all we need to do is move this 2x to the other side. How do we do that? We undo 2x by subtracting 2x from both sides. The 2x and the negative 2x on the left now cancel out. This leaves us with y equals actually what I'm going to do is switch the position of these two terms here to y equals negative 2x minus 3. The reason for this is later on we're going to talk about the fact that the minus 2 and the minus 3 have very special meanings. Later we're going to talk a little bit about minus 3, but we'll talk a little bit about the minus 2 another time. So there we have it. Our equation is now in function form. Another way to write function form, just as a side thing, is function notation. Function notation looks like this. The y becomes f with an x in brackets on the right-hand side. This is pronounced f of x, and it basically just means y. It's just another way to write it that I might demonstrate its use a little bit later on. And when the equation of a straight line is written in function form, we can describe the straight line as a linear function. The word linear, of course, comes from the word line, hence the expression linear function. Now that we have the function form, we are now ready to make a table. It always helps if you can write the function form right above the table before you begin. We are now ready. Let's fill in the first value here. When x equals negative 4, what's the y value? What we do, we put it into our function form. To get our first value, x equals negative 4, what is y? We take x equals negative 4, put it into our function form, and find the y value. Y equals negative 2 times x, which is negative 4, minus 3. Let's evaluate this. Negative 2 times negative 4 is 8. 8 minus 3 is 5. Our y value is 5, and that goes here. What that now tells us is our first point. A point is also known as an ordered pair. Two numbers that must be written in a specific order. And that order is negative 4, 5. These two numbers in this box are telling us that the straight line goes through the point negative 4, 5. Let's plot our first point, negative 4, 5. 4, 5. Do we need to write the coordinates next to the point? No, I can see you working in the coordinates in the table, so no need to write them again in this case. That's fine. It's all written there. Let's move on to the next one. X is negative 2. What's the y value? Again, we put that into our function form. Y equals negative 2 times negative 2 minus 3. This time it gives us y equals 1. This is giving us the ordered pair, negative 2, 1, which is another point for us. Let's plot our new point, negative 2, 1. from the origin, -2 to the left and up 1. There is our second point. For our third point, let's try x equals 0. But just for a change, I just wanted to show you this function notation. How would we do the same working using function notation? Let's put in x equals 0. That's pronounced f of 0 now. That means the y value when x is 0, which is going to be, simplifying this, -2 times 0, giving us -3. And in the end we can say f of 0 equals -3. Let's put that in our table. That is simply saying when x is 0, y is -3. Giving us a point or an ordered pair, 0, -3. Let's plot that. 0, -3 goes down 3. It does not go to the left or right. And that point is on the y-axis, of course. So now we have 3 points, which is actually enough, and we can see that they line up nicely. We have not made any mistake. That should keep the cranky guy happy. But let's complete the table because that's what we have been asked to do. Once we get this far and the x values are evenly spaced apart, you should notice a pattern once you've got 3 numbers there. Do we have a pattern? 5, 1, -3? Yes, we are actually going down by 4 each time. Let's continue that pattern. -3, -4, -7. -7, -4, -11. Let's plot these points on our coordinate plane. 2, -7. 2, -7. Oh, it does not fit on my coordinate plane. Let's try 4, -11. 4, oops, this one doesn't fit either. Okay, so we're only really able to use our first 3 points here, which is enough. But I feel really disappointed that these last 2 points went to waste. They didn't fit in our coordinate plane. You can extend your table and have more values if you like. I might try x equals -3. I'll just put it over the end. Let's find the y value for x equals -3. Putting it into our function form, we get y equals -2 times -3 minus 3. -2 times -3, 6 minus 3 gives us 3. Our y value for that is 3. Which gives us another point or ordered pair, -3, 3. Let's plot that on our coordinate plane. -3, 3. And once again, the points are continuing to line up very nicely. This actually demonstrates something very important. We chose the value x equals -3. We were free to use it. That is why the x value is called the independent variable. You are free to choose the x values. But did we have a choice on the y value that came out of the equation? We did not have a choice for the y. The y value came from the original equation. It was not our choice. That is why the y value is called the dependent variable. We choose the x values. It is an independent variable. But the equation dictates the y value. That is why it's called the dependent variable. So we now have 3 points. Actually, we have 4. So we are ready to graph our straight line. There we go, our completed straight line. Oops, I forgot the arrow at the bottom. Don't forget, we need arrows at the top and the bottom, and it should go all the way up to as high as your y values go, and all the way down as low as your y values go, also for the x on the left and right as well. Okay, fill your viewing window with the entire graph. And let's actually write the equation of the straight line next to the graph of the straight line. There we go. It's always good to write the original equation that we were given in the question. Earlier I mentioned that this number -3 has a special meaning. on the graph, it is actually where the line cuts the y-axis. This number here at the end by itself will always be where the straight line cuts through the y-axis. The reason for that is, in our table, we had the x value of 0. When we put in x equals 0, this term disappears. Negative 2 times 0 is 0, leaving us y equals negative 3. Hence, we get the y value negative 3, and that is where our straight line cuts through the y-axis, because this point has coordinates 0, negative 3. Let's add on a part C to our question. What is the domain and the range for our linear function? What is the domain of a function? The domain of a function is the list of all the possible x values that will give us a y value and actually give us a point. So recall, so far we have found y values when we used x equals negative 4, gave us y equals 5. Negative 2 gave us y equals 1. X equals 0 gave us y equals negative 3. So you can see our domain must be x equals negative 4, negative 2, and 0. But we also had y values for x equals 2 and x equals 4 as well. And don't forget, you also had a y value for x equals negative 3 when you extended your table. And looking at this graph, it goes on forever. In that direction and in that direction. It goes on forever in the left direction and the right direction. We will always get y values. Let's not forget earlier on we had two other points. One negative 5. That also sits nicely on the straight line. Negative a half, negative 2. That also sits nicely on our line. Wait, negative a half, so all fractions are included as well? Yes, all x values are included, all decimals, all fractions, they will all give us a y value, which means our domain is all possible x values. In other words, all real x. And a real number, of course, is any number that can be put on a number line. Another way to explain domain is that if you hold your ruler vertically and the ruler cuts the straight line, then that particular x value is included in the domain. So for the straight line in this question, a vertically held ruler will always cut the line no matter where you move it. Hence the domain is all real x. And next, of course, is the range. The range is the list of all the y values that are given by all the x values in the domain. For our range, all you need to do is think horizontally. Wherever the ruler cuts the straight line is where the range exists. Again, this includes all decimals, all fractions, any y value you can think of. So the range is all real y. So wait, does that mean I can put in x equals 100 and that will still give me a point? The answer, absolutely yes. Let's try it for fun. Let's put in x equals 100 into our function form. X equals 100. Y equals negative 2x minus 3. Putting in x equals 100 will give us y equals negative 200 minus 3. Negative 203, that means we have a point. X equals 100, y equals negative 203. You telling me that's on the line? Absolutely. That will be 100 that way and 203 down. And that would most definitely be on this line, a long way down there though. Hence we can say the domain and range are all real x values and all real y values. No matter how big they are, no matter how negative they are, they will always make a point on this straight line equation. That is the most important reason why we must put arrows, because the line goes up and down forever. Would you like a little more practice? I hope so. It's now your turn. Please try example 2. What did you get for the function form of the equation? Did the points you got on your table line up when you graphed them? Did you find any extra points that weren't in the table? If so, what were they? And what did you get for the domain and range? Should it be the same as example 1? Please share your answers in the comments and thank you for watching.